So where we left off, we're on session 4 on streams. Which I think really we are now going to commit is going to be the last of at least this series on streams. And what we looked at before is we spent the first one on this idea of these channels. And we saw how this channel is a general idea of computation that can accept multiple inputs and produce multiple outputs, and that it's powerful enough that we can actually represent all of the core streaming data types, the stream that's kind of the middle of a source of data, the pipeline that's the middle that's kind of transforming one piece of data to another, and then the sink that is consuming this data and ultimately doing something with it, all as these channels. And so they all compose together using these underlying operators on channels. And we saw that we could even represent ZIO itself as a channel if we wanted to. And then in the second session, we worked through that and we actually used this channel encoding to implement some channel operators of our own. So we saw how we could do a pipeline that did a stateful scan over some stream. So this says if you have some stream that is coming into you that has these in values, you're going to start with some initial summary value, and then you're going to produce a new output value for each of these. And so this we could imagine being like maybe this is going to do like a running total of numeric values for a stream, something like that. And we also saw how we could implement something like map. And then last week, we took that to another level, and we said, okay, how can we do things that are a little fancier? And so we started doing this stateful encoding and decoding with this low-level channel representation. And so I think Kit was up in Maine, and so we did this sandwich thing where we had some streaming sandwiches, and we had to parse the incoming sandwich data into the appropriate sandwich type. And we did that for one relatively simple kind of spec for how the sandwiches were encoded. And then we worked through, and I don't think we fully succeeded, basically mainly I think because we needed to just implement like a parser in doing a fancier sandwich encoding. And I think we had it to do of, I think at some point, maybe we'll, I know that ZIO parser is working on adding that streaming support, and maybe we could work on that live, or we could work on that at some point and kind of go over it together, or maybe we could have Daniel on again and talk about that. But at some point we may come back to that. But I think the basic takeaway was from the streaming perspective, it was actually really easy to implement this. You had to have the actual logic of doing the parsing, which depending on what you're doing, and if you're doing it very quickly without actually creating a proper parser, it can be more challenging, but the streaming part of it was pretty easy.
I failed this.
No, you were fantastic.
It hit me right afterwards that a better way of doing it, but I will not torture anyone again. I'll not write hand-rolled parsers on stream for a while.
So I think with all of that stuff, we got a pretty good idea of how we could do, well, I'll call maybe linear stream transformation operators. That all of these things, right? We starting from this first session here, we had this idea of you go to stream to pipeline, maybe you go to another pipeline, and then eventually you go to a sink. And we saw how we could implement these in terms of really what you're doing is you're going to read, and then eventually you're going to write, and you're going to do something in the middle. And we saw how with this low-level channel encoding, we have a lot of flexibility to do this reading and writing however we want to. Maybe we read and we realize, well, we need even more input. We need to read more before we have enough information to be able to write something. Or maybe we read and we want to write two things. We can do all of those things because we got this relatively low-level interface here. And then obviously we have all these operators that are built on top of it. So for common things, we don't need that. We have map and we have flat map and we have all these operators, but we need to drop down to that level. We can do that very easily. And so I think what we haven't covered yet is more of the cases where our data transformation pipeline here, we could call it, is not so linear like this. So if I try to represent this, in one pattern we might have here is we could imagine we've got input 1, and we've got input 2, And then what we really want is kind of these to go to like, maybe I'll just call these even streams just to, right? So we could imagine maybe these are like events from the East Coast and these are events from the West Coast, and we want to combine these together into one stream that has all the events. So this is what a lot of times would be called a fan-in pattern, right? Because we're kind of taking these two things and we're like, they're going in together into one. Or sometimes you can think of that as like it's a T, right? Of like you got the two things on the top and then they come together and there's just like one thing on the bottom. And the other variation of that is you could have more of the fan out pattern. And we actually saw a little bit of that, I think, in our first session where we talked about hubs. So this would be where we had stream one, and then we want that to go out into like stream two and stream three. So maybe we want to do the opposite here of maybe we've got this stream that has events that are both security events and generic and other notification events, and we want to send all the security events to this stream, and we want to further process the security events, and at the same time we want to take all the other notification events and we want to send them here, and we want to do some other pipeline with those types of events. And so you can think if you kind of have the ability to do this, and this, you have the ability to do arbitrarily complex graphs here. You can kind of send this thing around whatever you want to, and however complex your topology is, you can describe it as long as you have the ability to do these three things in the appropriate way. And I think one of the things we'll see today is there's some different like variations on like how exactly do you want to fan them in, or how exactly do you want to fan them out. But conceptually, if you can do all three of these things with the flexibility, then you can represent any type of topology you have. Does that make sense before we go on to a little more coding?
I think so. One of the left ones should be stream two, I think, says Adrian. But beyond
yes,
that,
that is 100%. That is definitely
I think
correct.
beyond that,
that was otherwise somewhat confusing. So thank you, Adrian. Yes, that's exactly right.
So you're merging two different streams into one stream, or fanning in, fanning out makes sense.
Yeah. And so one other resource that I would recommend for people, and I mean maybe Kit, you could grab this just so I don't navigate away from this, but there's this thing called reactive marbles that it's basically these like charts of you have these like colored marbles, and it kind of is like a nice way to visualize what some of like the different ways of combining or sending out look like. And I think one of the things we'll do today is we'll kind of create our own version of some of these. But I think a lot of times, like if you're kind of, what does something do? Like that can be a good site to go to see like, oh, okay, that's what it does. Or it can help you like frame the question in the right way. If you can kind of look through them and see like, oh, this is like what it does. It's called this. And sometimes the names are not exactly the same between streaming libraries, but they're usually close enough that you can either find it, or if you can't find it, like you can ask the question on like the ZIO Discord or something, and someone will know like exactly what you're looking for and can point you to the right thing. So that's kind of a nice, like a little bit of a kind of common language even for like different libraries that may do things differently.
I posted the link to that in the chat, and I also kind of started making some.
Yeah, I wondered. Yeah, that's perfect. Yeah.
Yeah, there aren't many of them there, but there, if you want to see, there are some ZIO specific simulations.
Yeah.
And I posted that link as well.
Awesome.
ZIO.surge.sh for that.
Yeah. Okay, so let's start with trying to do some of these. And maybe I'll call this fan in, fan out. And so I think last time we looked at, or the first time we looked at the hub and broadcast. So if we have fan out, let's say one of the common operators for that is that broadcast one we looked at. And so this says send all inputs to all downstreams. Right, so that was our idea of like, we've got a bunch of events coming in. and we want to send them all to multiple places, right? Every event needs to go to like the logging service, and it also needs to go to like the persistence service, and it also needs to go to the analytics service. So that's kind of one nice pattern for this. Another use case here is group by. And yeah, Copilot did a nice job auto completing for me there. But so the idea for this one would be, instead of every input going to every one of the downstreams, we instead want to select which downstream we want to send it to based on some key. So that would kind of fit this pattern of, we said before, maybe this stream has different types of events, and we want to send some events to this stream and some events to this stream. And so maybe we can create a little example of this here. So we could do something like, maybe we say stream 1. Yeah, I guess we can start with just some numbers here. So we got 1 to 10 here. And then what do I do? So I can do stream 1, and then I can do group by key, and maybe I'll group by whether they are even or odd. And then I get this lambda here, where I get both the key and I get each stream that corresponds to the key. And then this isn't quite right yet, because I want to do something with each of these. And so let's maybe look for a second, just the signature of this. So you see, when I do group by key, I give it a function. I give it a buffer size, which has a default value, so don't necessarily need to worry about that unless I want to change it. And it gives me this group by thing. And this just has this method that lets me take each of these streams and do something with them. And then it's gonna, at least this one's gonna collect them all back together for me. I've got a couple of other ways I can just like apply a filter for it. But right now I'm gonna do that. And so here, since I want us to be able to see something here, let me debug these, say. And then do val run. Let's try this. It's beautiful. And maybe this is going to be more interesting. Let me give it a even, and okay, so we had this original stream, which had 1 through 10, and then we are fanning out these 2 different streams from it, one of which has the even values and one of which has the odd values. And then the even values are getting doubled and the odd values are getting tripled. So if we look here, we see we've got 2, which gets doubled to 4, 4 gets doubled to 8. Or sorry, 1. Right, so sorry, 2, 4, and then we've got 6 gets doubled to 12, 16, and 20. So those are all the evens. And then the odds, right, we've got 3, 9, 15, 21, 27 here. So we see we've got these streams that are both running, and then this operator here, this group by key, in this case, is going to just collect them back into this arbitrary order for us. So here we don't preserve the ordering in this operator. We could do that if we wanted by manually recombining those streams. And maybe we could play with an example of that with the broadcast operator once we have some ways of explicitly recombining them. But this one's just going to do it in arbitrary order.
And
so
what is the What is the type of stream too, again? Sorry.
Oh, no. This is just the same thing. So this is a Z stream, any, nothing.
Okay.
And then, yeah, because I'm just.
Cool.
So between this and broadcast, I would say those are like I would say broadcast is maybe the most common way I see people do fan out. I would say this would be the second most common. There's another one called distributed width that is like super flexible. It gives you the ability basically to like look at the key and say, well, maybe I have 4 different downstreams. Send this one to downstreams 1 and 3. Send this other one to downstreams 2, 3, and 4. Send this one to like 4 and 1. So it's like very, very flexible. So like if you need to fall back to something else, like you can, but I find it's like so flexible that like most of the time, like your actual need is solved by one of these other ones. So then we can look a little bit at fanning in.
Oh, we do have one question. Is group
yes.
by sort of like partition? By...
Yeah, it's very much like partition. The main difference is this idea of recombining, and relative to like a collection, this is like a streaming version of that. So we're not like getting the whole thing and then having a collection of each of them that are in memory. We're like, as they come in, sending them to each of these downstreams. And that's where that buffer parameter comes in and is important here, because that's essentially how far ahead we can get with one versus the other. I think we actually have, yeah, so we have another operator that does a similar thing. So yeah, partition is kind of another example of doing this. The group by lets you support an arbitrary number of different streams, versus the partition just splits it out into exactly 2 streams. But the partition one is cool because it lets you hold on to some additional type information, so that the types of the 2 streams you're producing don't have to be the same type as the original stream. So this could be a nice operator if like you do have that case where like you've got like, let's say you have like sealed trade event, and then you have like case class security event and case class notification event. You could actually use this to split those 2 streams up and do something with each of them. So maybe we could actually even look at that. So like, let's say we had sealed trade event. Oops. Oh. And then we have object event. And then we had like final case class security event. And maybe it has a description. And I just call this a notification event. It also has a description. And then we could do see what will come. All right, so we've got these events here. Let's see if I can get my, okay, that's not working for me, so I will be typing it manually. So this is a stream of events here. Oops, and I think I probably have a spelling issue. Oops, no, hello. Oh.
I think it's just it's the object, so we need to import it.
Brilliant. Okay, perfect. And so here, like, let's say I had some methods. So let's say why don't we have something like doesn't seem bad. And then we have some way to process these notification events here. And let's see.
Should return string.
Oh, it should, yeah, exactly. Yep. So, yeah, for trusted compile here. Okay, so now.
Maybe actually to make it like a slightly, because just
Yeah.
to give them different types.
Make them different. Yeah, yeah, 100%.
You know,
Yeah,
like severity.
yeah, severity. Yeah, perfect, perfect. Love that.
Cool. Oh, and
Okay.
then got that.
So, yep. Great. Okay. And so if we just use like that group by operator, we'd have a problem here because group by returns, like it can work with like all these different keys, but every stream just has the same type and they're going to be streams of events. And so we're not going to be able to just process like the security events or the notification events versus here. So let's try. So we're going to do event stream. And then I can do partition either. And so I've either got a security event that has a severity inside it. Or I've got a notification event that has description inside it. And let's just see if we got our thing right here, or let's see. Oh, this is supposed to return a ZIO. Okay. So I'll just make this ZIO succeed here. So I have the ability to do ZIO workflows if I need to determine what type of event something is, but here I won't need to do that. All right. And so if we look, let's see, I have a feeling, yep, I'm going to need to do this myself here. So this should be, this is actually going to be a ZIO that has a scope, nothing, and then it's going to give me back a pair of strings. And so the first one is going to be a stream of
I believe
security events.
Oh, I see, yes.
And the second one is going to be a stream of notification events. Let's just check ourselves on that.
Oh, wait, I think, no, we would want to just basically return that because I think we're pulling out the severity, right? We just
oh yeah, sorry, or maybe yeah, you're right. I was doing because we're doing the destructuring here. Yep. Exactly. Perfect. Okay. And so now that I've got this thing, so maybe I could say like this is, call this partition. And so then I could do something like maybe down here, I could do, all right, so this is a ZIO. And so I could then flat map that. And I'm gonna just take this out so we can do our own thing here. So this gives me these two different streams, and then I can process them both. And then there are a couple ways I can put them together if I want to. So let me first maybe show a kind of more like ZIO way, and then we'll look at a more like streams way. So one way I could do it is actually, I don't even need to do that. I could just do
Ooh, symbols.
oh, and I think I have one extra in here.
That's zipar, right?
Yeah, exactly. Yes. So basically, okay, I want to take my original stream. I want to partition it into these two. And then in this case, I just want to kind of run this thing with each of them. And I want to process these events. And so let's try running this for a second. Okay, so we see that did what we wanted it to do. Now this case, you can see we're using just like we're running each of these streams, and then we're using a ZIO operator of zipar that we're used to. So this is a nice pattern if we are at the end of the world in our streaming application. We're done streaming, and okay, we actually want to do the things. But let's look a little bit about how we can stay more in the streaming world. So I think here the first thing I'll do is I'm just going to extract these two streams out into, so I'll say maybe processed security events. And then I'll say process notification events. And so here we've done the fan out, right? Partitioning was doing the fan out for us. We have these two streams. We've done stuff with the two streams. And now we've got like a really, I would say, common problem where like if we don't want to just run the streams, we need to ultimately return one stream, but we have two streams. And so what we essentially need is we need one of these fan in things. And I would say this is a very common thing where when you have the fan out pattern, like often you're eventually going to want to fan back in. So you're going to end up having a stream 4 over here. And so it almost makes a diamond where like the data splits out, it gets processed by different people, and then it comes back together. Even if it's just running this whole thing, maybe that downstream just wants to run everything. It's not going to do a whole lot of them, or maybe it's going to take the inputs from both of them now that they've been processed in parallel at this stage, and it's going to do further processing with them. So this is a great, I think, transition for us into some of the operators for fanning in here. And one of them that is I think particularly nice is this merge. And so I think I can actually, so let's just start with this for a sec. So you can see I've merged this into one stream. So maybe let's do val merged. And I think in this case, actually, so here, see one of these returns an int, one of these returns a string. So we're kind of going to throw away that information. So maybe I'll actually, let's see. Well, maybe that's fine, at least in this case. We can think about how we change that later. So we've got this merge stream. And then eventually, at least to satisfy this run method here, we are going to have to do something with this. So here we might then do this run drain on this stream. And let's try running that. And so you see we basically got the same thing. And so this merge is the first way of fanning in that we're seeing. And it's basically saying, take the values from both of them, don't combine them, but just take them and then emit them again, and take them as fast as you can from both sides. So this is a little bit like you could think of like maybe the stream version of racing a little bit, of just take more stuff as it comes in. Yeah, and perfect. You're doing exactly, yeah. So we can be a little bit more strongly typed here. So then this is going to be an either interstring here.
Yeah, though as it, I mean, since we were never actually using that any value and just running the stream, it doesn't matter.
Yeah,
we just show that it can be smart, but we were just trying to get the super type of string, which is
yeah.
We did have a couple of questions. Union types could be nice for sure. Let me see. So let me start from the bottom. So if our sum type is more than 2 terms, is there a method to get nicely typed streams with partition either? I think that's kind of a limitation here, even with partition, right? So partition map on collections or something, like you kind of need to return an either, or it needs to be special cased or some like ternary type that has 3 type parameters. I think there's some special things with heterogeneous lists and macros that have been implemented by other libraries, but I don't think that's built into ZIO currently, or maybe there's, how would you solve that problem? If you wanted, the type safety of partition either with more than just 2 sides.
Yeah. So I think there are 2 maybe ways I would think about it. So one is like, you can always implement the more than 2 just in terms of doing the 2 version more than once. So if we had like 3 cases, you could say, well, let me first partition into like the left is the first 2 cases and the right is the 3rd case. And then let me partition again the first 2 cases into the first and the second, and then you would get your 3 streams. Now there's a little bit of like boilerplate and kind of moving the types around to do that, but that's kind of one way to do that. The other way that I think can be pretty nice is you could just use like broadcast, say, and then you could use the collect operator. So like, let's say here, I broadcasted like all the security, maybe I have 5 types of security events. I can broadcast all these security events out. So I've got like 5 streams of security events, and then each one I can do .collect. So let's just look at that for a sec. And I could just say, well, if it's a security event, then return that thing, and otherwise this partial function doesn't match. And then I'll get these 5 streams that are each my type. And that was actually reminding me, there's this kind of nice operator that someone implemented called collect type, which can be kind of cool for that, where you just literally say the type of the thing you want to collect, and it'll collect the things that are that type, and it'll just throw the other things away from the stream. And one of the nice things about the stream is it's kind of type safe to do that, because the stream doesn't promise that it has a value in it. It just promises it has 0 or more values. So if you collect something you don't have, you won't have anything, but you won't have a runtime exception there. So I think that was originally something that was in akka, and I think as a ZIO contributor implemented that. So that can be a nice thing if you kind of have that pattern.
Cool. And I think there was another question as well, though I'm not sure I fully understood it. So please, yeah, it looked like it was doing reflection. There was a class tag. So, I mean, it was using the class tag.
Yeah, and so there's a little bit of like, if you don't want to do that, just go back to the normal collect and just do the pattern match yourself. But if you want to, this can, and that's okay, this can be a little bit more ergonomic if you want it.
So there was another question, which is, how can we interpret the results being streamed in terms of pull? And I think this was asked 15 minutes ago. So I'm not exactly sure the context. Let me read the second part, because it seems as if we're pulling from stream 1 and pushing into one of the streams, but ZIO streams are pull-based, aren't they? So that's a, yeah, I also see you're typing one, so maybe there's a clarification. But is there enough there for you to understand that? It seems like it's around, in the context of the first example of group I, thank you. So in the group I example, basically, yes, since these ZIO streams are pull-based internally, how are we seemingly, I guess, pushing to these other 2 streams?
Yeah. So what you'll see in some of these stream operators is there's some kind of, so let's go to like group by here. Maybe let's do group by key. And so you'll see there's this parameter for like a buffer size. And when you see a parameter like this, it's a clue that there's somewhere basically a queue that's being used here. And that's something that's relatively common in concurrent streaming operators. We try to use as little as we can, but that's kind of where that world of like when the push-based and the pull-based world meet, the way they meet is basically with a queue. And so without getting to kind of the whole implementation here, what this is basically doing is you're reading from the original upstream, and you're determining which you're using this keying function to get the appropriate key, and then you're going to offer it to one of these inner queues that correspond to each key. So like each key's got a queue associated with it, and you're going to offer it to that queue. And so the buffer size is kind of where that like meets of like ideally you don't want the buffer to be too big, because then like the upstream can kind of go crazy and like produce too much, but you maybe don't want it to be like literally 1, because then like every time before you can have the upstream producing more, you got to get the last one. So that's where that comes in. But yeah, I mean, I think that's definitely a good observation. And if you go into the implementations of some of these operators, you'll see that you have some implementation like this here. And so like if we kind of go to the highest level versions implementation, what it's saying is make this data structure. It's basically, it's like map of queues. So for every key, you're going to have a queue. And then make this queue here that's going to have these inside that you're this big kind of handling the shutdown. And then what we're going to do is we're going to take the original thing and we're going to send it to this group by key channel here that's going to actually send it to each of those queues. And then we're going to run that thing and we're going to fork that off in a separate fiber. And then we're going to essentially just drain this final queue that has all of those inner queues, and we're going to merge them back together. So yeah, you're definitely right that a lot of times there is going to be some element of buffering that goes on there in some of these concurrent stream operators.
Nice. I'm glad we went over channel a little bit. It wasn't the most complicated in the world, but yeah, definitely more complicated than what we did the other day. Sweet. I think, well, that was it for the backlog, but as far as I've seen,
cool.
Feel free to re-up them.
Cool.
But I think
all right, so let me show one thing here just to try to clean this up a little bit more. So here you can see we partitioned this thing out and we got these two streams. Now here we we merged the streams back together, but then we had to run them. Let's say we wanted to describe this merge stream as its own just stream. So we'll say val merged. And what we would like this to be is a Z stream that doesn't require environment, that can't fail. And it's a stream of this either ints or strings here. So how would we do this? And so we could start by, I'm just going to copy my code here, even though obviously it's not going to work yet. So I'm going to want to get rid of this thing here. I'm not going to want to run it. And I'll do the merging here. And let's see what type we get here and what we can do to kind of fix it. So why do I have two? Oh, all right, let me see if I can, I think I can fix this by giving myself, so the first thing I'm gonna do here is I'm going to change this to be a map, because the flat map was trying to expect this to be a ZIO, but it's not, it's going to be a stream. And so then let's look at what I've got. So what I've actually got is, well, I'm going to copy the other one and then we'll kind of compare in a second here. Okay, so what I want to have is just a stream that has this stuff inside it. But what I've actually got is a ZIO that's got a stream inside it, and the ZIO's got a scope here. So does anyone know what the operator would be for me to get between these types? So generally in ZIO, whenever you've got a type that's in a ZIO and you want to get the type out of the ZIO, there's an operator called unwrap for that. So the first thing we could start with is we could say zstream dot unwrap this whole guy. And then the only other, so that's basically going to take care of everything for us except the scope. And we're in fact even now close enough with our type signatures that because we're in a ZIO app default, Kit's like nice logic is going to kick in. And so we don't even get like our little bit hard to read error messages here, but we see this like, you have the scope. What are you going to do about the scope? And the way we do that is we just use a variant called unwrap scoped. And so now this is essentially going to do the same thing as what we had in our previous implementation down here. It's just giving it back to us as a stream. And so now this is like, okay, it's nice. We can compose it with other streams if we want to do more things downstream of it. So now maybe we want to delete this whole thing, and maybe that we want this to be like merged, and maybe we'll add another debug here. And then we'll run this thing. Oops. Okay, and so you'll see, so we've got the notification stream, which does hello, goodbye. We've got the security stream, which does 9,000. And then we've also got the merge stream, which has all three of them wrapped in a left or right. And then finally, we see the final result, which in this case, we collected them all. We didn't have to collect them. A lot of times, if we had too many, if this was a large stream, we wouldn't want to collect them all. We would just want to do something like run drain here and say, look, we're just processing them in the stream. We don't need to collect them. But right now we're collecting them, and there we go.
Boom.
All right, so let's look at some different variations of how we can fan in. So we looked at merge. Maybe I'll just list some here and I'll kind of give the textual description, and then folks can say, like, are there others they can think of? Maybe we'll try to put together a list and then we can figure out which ones we want to kind of do examples of. But so this you could basically think of as pull from both upstreams as quickly as they have stuff and emit essentially unchanged. And we could probably find the like reactive marble for that. But so basically, if we had something like, I don't know, red, blue, and then our other one was red, green, we would get something that, and maybe I'll do the like little spacing out thing. So like if here's how it came out, then this would be red, red, green, blue. And I don't know, maybe kid in the, oh, thank you, yeah. And maybe one thing we can do is we can actually create some little streams with like some schedules so we can like illustrate this. So we could do like sealed trait marble, object marble. So this one is going to be, so this one's red and blue, right? And then stream 2 is going to be red and green, right?
Mm-hmm.
And then why don't we do,
what if we,
this? Yeah.
What if we had sort of like a made a little helper that took something like a delayed,
yeah, exactly,
something that took a
perfect
some value. So it took like, what would it take? A list of, let's even do values. So a tuple of a and a ZIO duration.
Yeah, I think that's a great thing for us to construct.
And then could return a Z stream of any nothing. Okay, so yeah, how do we, sure there's some helper on this that we could make that pretty easy.
Yeah, I think easy one might be to do unfold ZIO.
Okay, so that would be Z stream dot unfold. Then we get autocomplete ZIO. So I'm guessing we start with some beginning state. No, maybe not.
Well, I think what we might want to do is we might want to match on the values and see if there's exactly one thing here. So like, what if we did something like values match? And then we could say, oh boy, this is so if so if there are no values, then we can emit the empty stream, right? If there is a value, then I think we could do something like Z stream dot from let's see, oh, this is expecting so here then
does this actually, would this actually work recursively? I guess it theoretically should, right?
Yeah, I think we could actually try some. I might want to do
plus is lazy,
yeah.
right?
Yeah, let's I think let's give this a shot. I was going to implement a slightly different way, but that way is fine.
No, I'm
too.
sure there's maybe a better way, but it's kind of cool that it kind of look like a map or something, or a fold left or something.
Yeah. So okay. So this one, first one's going to be marble.red to, let's say, 1.second. Oops, should be an arrow. And then marble.blue. I guess yeah, let me do lowercase because that's what I actually did. To 4 seconds.
Okay.
And first, let's maybe try running these streams and make sure that our little operator here is doing what we want it to do. Mm-hmm. So we're gonna, oops, okay, so this, yeah, okay.
Delay is not a value of stream. Oh, yes, of course. Yeah, from ZIO. Cool.
Yeah, let's get this. Oops. We're just got stream ones above, so maybe we should call this like left and right.
Yeah. And then let's try left first.
Yep.
It's taking a while. Oh, because we're
are we
printing anything.
Right, we should yes, so we want to debug this.
Got debug then rendering. Cool. Yep. Nice.
But it seems like it was just some delays and it completed. So that's,
yeah, it took around 4 seconds. Red, 1, 2, 3, 4-ish. I counted quickly. That was about right. All right, sweet. So let's merge it and see if it's in the right order.
Oh, this is doing incremental delays between each one.
Oh yes, because
so
of course.
Yeah, so maybe let's have this delay 2 and 1. I mean, we could do it another way, but just so we kind of don't spend too much time on our little implementation of our.
So yeah, so it'll be yes, 3 seconds after this one. So this will start at 2, and then so yeah.
Yeah, exactly.
Everyone's got to keep. But theoretically, what we're doing is making this graph work. So
yes. All right, so let's now try merging these together and let's see what we get. Let's see if we get the expected result here.
So red, green. Oh, we have no green, but whatever. So let's put green in there. Green.
Oh yeah, that.
Now it should match.
Okay, so we got red, blue, and red, green. Okay, let's do this again.
Red, green. Ooh, lovely.
All right, excellent.
Beautiful.
So this is one thing we can do. We can merge them. Let's look at a couple of other things we can do. So we can do zip, which is pairwise combine them. Pull from both upstreams and emit one value once you have a value from both. So, and oftentimes we'll do zip, or this zip with is just a variant that lets us combine these with a function. So let's try zipping these streams together.
Red, blue, green.
So you see here versus the other one, we had this like 1-to-1 correspondence of we had 4 marbles in, we got 4 marbles out. In this one here, we have essentially a 2-to-1 correspondence, right? Of we had 4 marbles in and we get 2 marble pairs out, or maybe we end up mapping them to something else. And the other thing you'll notice here is that because we need both of these values to emit the next pair, we only emit when the slower one has something. So we essentially got red at 2 seconds in this example, and we got blue green at 4 seconds in this example.
And I think there's another, I mean, I'm sure we're going to keep going through these. I forget what it's called. Is it called zip latest or something? Oh,
zip with latest, exactly, yeah. So there's another variant of this. So sorry, just stepping back for a second, like think about applications. So the zip one is nice, where you kind of, you need information from both of them, and there's some like logical correspondence between these two, right? Of you have like a stream of document numbers and you have a stream of the actual documents, and you need to combine them, and like each, the second document number goes with the second document, and the third document number goes with the third document. You want to kind of keep that pairwise relationship. But there's this
like zipping a list. It's the same.
It is 100% zipping a list. Yeah, this is where like the collection analogy is like really good. The streams have more operators, but the operators that are collection-like behave very much similar to the collection operators. But so this zip with latest one will pairwise combine them. But what it's going to do is it's going to pull from both. It's going to hold on to the last value seen from each side, and it's going to emit the new value plus the last value from the other side. And let's do our little marbles here, because that's probably easier to see than. So here, we still need to emit pairs, and we made a little more spacing here. So at second one, when we just have red, we're not able to emit anything. But then when we get a second red, we're immediately able to emit red, red. Oops. Then we get green in here at second 3, I guess.
Right. Yeah. So move everything else.
Yeah, exactly.
Down. Which way was it? Oh, green. Yeah, there we go.
And as soon as we get green here, we've got a green from this side, and we held on to the red that we had from the first side. So here we're going to get red, green.
Mm-hmm.
And then the final thing we're going to get is we're going to get blue here. And so now we've got, we're going to blue here. And so we got blue from this side. We've got green from the second side. And so we're going to get this blue, green here. And so the zip with latest is really nice when these represent like a lot of times some type of event, and you want to work off of the latest information you have, whatever latest information you have. So like imagine this was like the stock price of Apple, and this was like the stock price of like Microsoft. So, and you want to like do some trading logic based on these two prices. So Apple stock price comes in, well, you're like, okay, that's fine. Like if I don't know the price of the other thing, I can't trade anything. Then here, okay, I got a new Microsoft price, so great. I've got the pair of the Apple price and Microsoft price. I can maybe do some kind of trade. Then you get some new Microsoft price. So you're like, great, I've got a new Microsoft price. I've got the old Apple price. And then finally get new Apple price. So like, okay, I got the latest Apple price. I got the most recent price from Microsoft I've got. And so you always have the latest information available, whatever that is. I mean, some of it may be a little bit old than others, but at least it's the latest information that's available in the stream.
Yeah, and in terms of a concrete use case, I mean, I don't really do this too much in the back end, but when doing sort of using Laminar, which is a functional reactive programming framework for the front end, where basically all user events and interactions are essentially streams, event streams, you basically combine all of your streams with something like zip with latest, whatever it's called, because you care about like the current user's mouse position and the current state of the DOM. You don't care about zip wise, doing a pairwise zip so much. So zip with latest tends to be in reactive like UIs, the default way of zipping these things.
Yep.
Cool. We probably want to zip with latest or just a zip latest. I've always wanted that. That's a to-do.
Oh, well, maybe we should.
If anyone wants to implement zip latest, I don't think that's ever shown up. Maybe it is.
Yeah. We could definitely do that.
Where oh yes, so we got a good question, and I'm not sure the answer actually, which is there does this use zippable? So if we zip 3 things together, will it be nested? Will it be a nested tuple or not if we just use zip?
That's a good question. So I think let's see if we can look here.
That's zip.
Normal zip. It uses zippable. Yay, zippable, my old friend.
Nice. All right. So maybe zip latest could also use zippable. That would be pretty cool. Nice. So yeah, if you zip more of these, it will not be a nested tuple. Great. Go consistency.
Yeah. So we got these. I would say these are some of the more common ones. Another one that is occasionally useful is there's one called interleave. So this one is very collection-like as well. And so this will basically go back and forth between pulling one and the other. So this might be useful in a case where like maybe you have one set of sample data and then you have another set of sample data. And you want to combine them into one stream of sample data, and you kind of want to like fairly go back and forth and like pick from this data, pick from this sample, and kind of pick from one or the other. So that's kind of cool. And then if you want to, there's a fancier version of this that basically lets you also give it like a stream that decides each time like which side you want to pull from. So like here, you go back and forth of essentially true is pull from the left and false is pull from the right. And so here you just pull left, pull right, pull left, pull right. But if you wanted to, you could do some fancier thing where you said, well, like pull twice from the left and then pull twice from the right, or do like pull twice from the left and then once from the right. And so you do like a 2-to-1 mix or something. So that's another set of stream operators you've got. I'm trying to think of what's that?
I said cool. Yeah, there's just the complexity of this space, right? It's all the complexity of collections. So you might have multiple elements, but then also adding in the temporal vector there, whatever axis. It gets there are probably an infinite number of combinators we could have, and there's certainly more than on just normal ZIO.
It's one of the really interesting challenges, because when you have ZIO, you have this case of like ZIO is either not done or it's done with exactly one value, right? And so what that means is that like if you've ever like read some of the stuff for like ZIO Prelude or like heard someone talks about that, there are actually like a very, very limited number of like ways that you can combine these two values. You can say, well, run the first one and then run the second one. You can say, run them both in parallel and return both of their results, right? That's like zip versus zip par. You can say, run them both and return the first one. That's race. And then you could say, well, run the first, but if it fails, run the second. And that's or else. And those four, I would say, pretty much cover like all the ways you can combine running two different ZIO workflows. Versus with streams, you can see we've got like all of these more things, because instead of just having one value for each, you've got between 0 and an infinite number of values for each. And so I think you're exactly right, Kit, that there's at least potentially an arbitrary number you can come up with of combinations. Now, I think there's probably a much more finite number that are like practically useful, but it still ends up being much more, because we can have all these different patterns of like, if I've got these like two different like streams of marbles, how do I want to pull from these different streams? And I think we've probably seen the big ones, but if you go through the streams API, there are definitely some other ones that are more specialized for certain use cases.
I would be curious to know if people in the chat would like to share, just if you are using ZIO streams, how you are using them. I guess.
Yeah.
In my day-to-day work, I use
Capstone
mostly quite simply. And I because I guess I'm not working on like, I'd assume like big data processing pipelines and stuff like that. And yeah, I mostly use just plain old ZIO if I'm revealing my ignorance with some of these operators. But yeah, I'm curious. It would be good to know like what are some good, where has it served you well? And also if you have any questions about your specific use cases, I mean, we could definitely come back to streams. Yeah, but I think, man, I think we covered a lot of a lot of ZIO stream details. Are there any thoughts for, are we going to do more streams next week, or is this sort of the end of our planned stuff? And let people ask for me.
I think this is the end. I mean, at least I think we already kind of said last one might be the end, and then we didn't. So I think we probably should like actually like honor ourselves there. But I mean, if people want more, we can definitely change the plan and do another week on it, or we can always come back to it relatively soon. But yeah, I really like what you said, Kit, about kind of, I'd love to hear from folks too. So, I mean, maybe we can give folks a minute to type. I guess while they do that, I'll kind of say, I can say a little more, at least from my perspective. I think you're right. I think the vast majority of people I see using streams, like they want to use existing stream operators. Like I think hopefully it's cool and empowering to do more of this low level stuff. But I think generally people want to just like they want to do the zip with latest, they want to do the merge, they just kind of want the operators that do the things versus having to get into this kind of complexity of streams. They just kind of want the streams to work. I think we've covered most of the like big operators. I think one that, at least for a set of users, is important is this aggregate async one and its variations. Particularly, there's this like this fancy one called aggregate async within. And so this a lot of times I see used, like this is used in like ZIO Kafka, which is one big kind of set of users of ZIO streams. And so this has these semantics of essentially you're going to read from the stream and you're going to keep aggregating values with the schedule, or sorry, with the sync until this either the sync says it's done or the schedule says it's run out of time. And then you're just going to do the same thing again. And so this can be a pretty useful operator if you're like, you want to aggregate your data somehow, right? Like you've got all these records coming in and you want to like group them up and kind of batch them into like some like summary value. So like you don't send all this stuff downstream individually, but you want to have some control over like your latency of like, maybe in a simple world, you'd say, well, I'd like to group by like 1,000 records. But then you like say, well, you know, if I got 900 and 5 minutes have passed, I don't just want to be like sitting here like holding on to these records. I want to send them downstream, even though I don't have 1,000. And so this is a really nice way to do that, where you would do that with like ZSync, like collect all n 1,000, and then you have some like schedule.fixed 5 seconds. And that would basically say, well, collect in batches of 1,000, but if you ever have 5 seconds or pick your number 1 second, 50 milliseconds pass, then just send what you have and repeat the process. So that's probably another one I see people using, at least indirectly, pretty commonly.
Nice, and we got an answer from Navid, which is that it's a wrapper around Kafka, so that makes sense.
Exactly.
Yeah, if you're using a streaming library, you're probably going to want to process it with another streaming library and adapt it. But yeah, cool. Well, that's great. Thanks,
awesome,
everybody. If we've learned,
thanks so much for joining.
Definitely hit us up in the Discord or on the GitHubs. Other than that, we'll see you next Friday. Thanks, Adam.
Yeah, have a good day, everyone. Enjoy the long weekend for folks in the US. Bye.
Bye, everybody.